Are you an AI ML enthusiast and you want to learn the basics of research? Or do you have an idea in your head but you don't really know how to structure it? Or are you just AI ML job hunting and need help restructuring and polishing your digital portfolio to get the interview job calls? If this is of interest to you, please subscribe and like this video. And this is Career Coach bringing you all the answers to these questions. So far, we have been running this 10-week-long program called Build Your Own Research Internship in AI, and this is week 6, where we start bringing original research contributions to the table. So in today's session, we will learn, given that we've already started baselining some code from existing GitHub code bases, and now the idea is how do we come up with the right hypotheses or research questions, and how do we come up with the right experiments to either accept the hypothesis or negate it. And so we will be learning what we are going to be doing in the next coming weeks in order to come up with our research questions and the experiments that will be able to then show, is this research structured in the right way to answer the right research questions or not? The topic at hand, advances of deep learning in medical image processing. So keep watching. Okay, so today we will learn how to bring original contributions into research, and what we will see is how could we come about, what is the steps that you need to take in order to conduct original research. So let's get straight to it. So let's look at the story that we have had so far. So far we have implemented 2 methods for medical image data augmentation. The first one, or the method M1, actually uses standard Keras environment, and it has the data augmentation function that you pass parameters to. And what this data augmentation parameters will do is it'll set limits to which you can zoom in, zoom out, share, rotate the images, so you can generate several versions of zoomed in and zoomed out and different angles of the same image. And then since last week we have started implementing this other method, or M2, which generates tiles, or it subsamples the images, right? So they're overlapping subsamples, and then these subsampled images now become a new volume of data that is then subjected to image segmentation. So M2 is able to generate a huge volume if you pick smaller enough tiles, and in order to then pass to the UNet. So I will be linking the last video in the description box below so that you can watch it in continuation. Now, in research, you always have to think about it in terms of a hypothesis, and you experiment build experiments around this hypothesis, and then you test it. Is the hypothesis true or false, right? So then those are called your research questions. So what are the possible research questions that can crop up based off of the work that we've done so far? The 2 research questions that are very obvious is, first of all, is M1 better than M2 for data augmentation, or is M2 better than M1? So we've seen that both have different model parameters, and that's why you first need to do some sort of standardization application, and after that you have to have these experiments which will tell you that which one is better, especially for your application, which could be your retinal image segmentation, or it could be facial segmentation, or whatever, you name it. And the second one we want to answer is there a way to combine both models M1 and M2? So is there a way to maybe generate a pipeline? Is first, go through M1 and then do M2, or do M2 first and do M1, or combine them in some other either hierarchical fashion in order to generate even a better data augmentation generator, right? So make sure that in this case we are trying to keep it as generalizable as possible. And then is there even a way to conduct experiments to see if a combination would be a better solution at all? So let's see the steps towards answering both the research questions. So let's look at the first hypothesis, and there we're trying to see is M1 better than M2 or not. So the step 1 in this case is standardization of the methods. We saw when we implemented M1 and M2, both have different system level parameters, and what we need to first do is ensure that the parameters for both M1 and M2 are exactly the same, so that we can actually do an apples to apples comparison between them. So the requirements in this case that we are fixing is, first of all, grayscale inputs for both models. Then also we are ensuring that input and output image sizes are 512 by 512, and there's a reason we picked this 512 by 512 is because the drive data set, the sizes of the images are about 565 by 545. So this is the closest match, or a square match to those dimensions. Up until last week, we've seen the performance of M1 for image input size 256 by 256. So that's why I'm saying we need to standardize it and ensure the sizes are always the same for M1 and M2. Then the third requirement is what we're using is UNet with a depth of 4, and that's what we saw last week is you could have different depths for UNet. You could have 3, 4, 5, or even 2. So shallow versus deep. The only downside of having a deeper network is that there are too many parameters, so you might end up overfitting it if you haven't trained it with enough images. And having too shallow means it's not generalizable at all. So it's underfitted essentially. So and the other last two things is, again, what are the loss function for UNet. So in both cases we are fixing it to cross entropy loss, and we are reporting the metric as accuracy. And I've already given out the evaluation function, so that's precision recall, accuracy, intersection over union, and F1 score. And I will linking the Google Drive as well in the description box below with the drive where I have this code available for anyone to use based off of their needs. Now let's look at the results for this experiment that we did for the standardization, and this will help us prove or disprove our first hypothesis. So this is the outcome of M1 and this is the outcome of M2. Now let's look at it qualitatively. You see, for M2 you have very fine vessels which are detected, and M1 actually has these finer vessels absent. So it's not actually able to capture this very fine thin vessels as you go deeper into the fine-grained version. So there are definitely false negatives in M1. And then also you see this case is where you have lesions very close to the blood vessels, and M2 is able to eradicate or pick vessels versus lesions very well in this case. But M1, you see, they are still having some false positives. So M1 has both false positives and false negatives. So in which case we see the F score of M1 is 0.75 while that of M2 is 0.81. So clearly we have concluded for the first research question that M2 is more effective for this particular data set, so for blood vessel segmentation, than M1. So now the next hypothesis, or the next question that we need to answer, we can look at is, could combining M1 and M2 further improve segmentation? Is it possible to even come up with such a pipeline? So what we want to do as our step 2 and following weeks to come is, first of all, we will be generating a zoomed in, zoomed out and shared version. So first of all, we will be using model M1 to create an augmented generated data set of D1. And second, what we will do is we will subject this D1 to further tiling or into M2, which will generate this augmented data set D2. So it's not just using either M1 or M2, but first using M1 and then using M2 to come up with this new augmented data set, which is D2. And what we then want to do is we want to evaluate D2 for UNet segmentation at different depths. So we can have a UNet depth of 2, 3, 4, and so on and so forth. And then finally, we will be doing ablation study, which is super important whenever you are doing deep learning especially. And what happens in ablation study is you modify all the requirements that we saw in slide number 3. So that is, your color, is it grayscale or color, is if it's the image size, or even the depth of UNet, and you modify that and you see which one is the best version and why the others are not good enough. So why you need to answer these questions and analyze why a certain number of parameters is the best option and why the others are not. And that is what's to follow in the weeks to come. See you next time.